According to the 2002 National Electrical Code, power-limited fire alarm circuits are generally not required to be installed in conduit. However, there are exceptions to this rule. These exceptions mandate the use of conduit in specific circumstances to ensure the safety and integrity of the fire alarm system. Firstly, the National Electrical Code Section 760.121b states that power-limited fire alarm circuits must be installed in conduit when passing through fire-resistant rated walls or floors. This requirement is in place to maintain the fire rating of the structure. The conduit provides a protective barrier that helps to prevent the spread of fire and smoke through the openings created by the wiring. Secondly, according to the National Electrical Code Section 760.121c, power-limited fire alarm circuits are required to be installed in conduit when they are exposed to physical damage. In areas where the wiring is susceptible to being hit, crushed, or otherwise damaged, conduit provides a robust layer of protection. This helps to prevent shorts, open circuits, and other malfunctions that could compromise the fire alarm system's functionality. Thirdly, National Electrical Code Section 501.3 requires conduit for power-limited fire alarm circuits installed in hazardous classified locations. Hazardous locations are areas where there is a risk of fire or explosion due to the presence of flammable gases, vapors, liquids, or dust. In these environments, conduit provides an essential barrier that helps to contain any potential ignition sources and prevent them from coming into contact with the hazardous materials. It's important to note that the specific type of conduit required, such as rigid metal conduit, electrical metallic tubing, or flexible metal conduit, may vary depending on the specific application and the requirements of the local electrical code. Always consult the applicable codes and standards to ensure compliance. In summary, while the 2002 National Electrical Code generally does not require power-limited fire alarm circuits to be installed in conduit, there are several key exceptions. These exceptions include when the wiring passes through fire-resistant rated walls or floors, when it is exposed to physical damage, and when it is installed in hazardous classified locations. Understanding these requirements is essential for ensuring the safe and reliable operation of fire alarm systems. It is essential to understand the characteristics and requirements of fire-resistant rated walls and floors. These structural elements are designed to prevent the spread of fire for a specified period, typically measured in years. When electrical wiring, including power-limited fire alarm circuits, penetrates these barriers, it can compromise their fire resistance rating if not properly protected. The purpose of encasing the wiring in conduit is to maintain the integrity of the fire-rated assembly. The conduit acts as a protective sleeve, preventing flames and hot gases from easily passing through the penetration. The type of conduit used should be appropriate for the fire resistance rating of the wall or floor. For instance, metallic conduit, such as rigid metal conduit or intermediate metal conduit, is often preferred due to its inherent fire resistance properties. The installation must also include proper fire-stopping materials to seal any gaps between the conduit and the surrounding structure. Fire-stopping materials are specifically designed to resist the passage of fire and smoke, thereby preventing the fire from spreading through the penetration. Selecting the appropriate fire-stopping material is crucial and should be based on the fire resistance rating of the wall or floor, as well as the type of conduit used. Always refer to the manufacturer's specifications and the applicable building codes for guidance. In locations where electrical wiring is exposed to physical damage, the use of conduit is essential to protect the conductors from mechanical stress, abrasion, and impact. This is particularly important in industrial settings, commercial buildings, and areas with heavy foot traffic or equipment movement. The National Electrical Code defines various types of conduit suitable for different levels of physical protection. Rigid metal conduit provides the highest level of protection against physical damage due to its thick walls and robust construction. It is commonly used in areas where severe impacts are likely, such as manufacturing plants and construction sites. Intermediate metal conduit offers a lighter weight alternative to rigid metal conduit while still providing a good level of protection. It is suitable for use in areas where moderate physical damage is expected, such as commercial garages and service areas. Electrical metallic tubing is a thin-walled conduit that is typically used in concealed locations or areas where the risk of physical damage is low. While it is less robust than rigid metal conduit or intermediate metal conduit, it still provides a degree of protection against abrasion and impact. Flexible metal conduit is used in situations where flexibility is required, such as connecting to motors or equipment that vibrates. It is less resistant to physical damage than rigid metal conduit or intermediate metal conduit and should be used with caution in areas where physical damage is a concern. When selecting the appropriate type of conduit for physical protection, consider the severity of the potential damage, the environment in which the wiring is installed, and the applicable electrical codes. Hazardous classified locations are areas where flammable gases, vapors, liquids, or dusts are present, creating a risk of fire or explosion. These locations are classified according to the type and concentration of the hazardous materials present, as well as the likelihood of their presence. The National Electrical Code Article 500 provides detailed requirements for electrical wiring and equipment in hazardous classified locations. The primary goal of these requirements is to prevent ignition of the hazardous materials. This is achieved by using explosion-proof enclosures, intrinsically safe circuits, and other specialized equipment designed to contain or prevent explosions. Conduit plays a critical role in maintaining the integrity of these systems. In hazardous classified locations, conduit is typically required to be sealed to prevent the passage of flammable gases, vapors, liquids, or dusts. Sealing fittings are used to create a barrier within the conduit system, preventing the migration of hazardous materials from one area to another. The type of sealing fitting used should be appropriate for the specific hazardous materials present and should be installed in accordance with the manufacturer's instructions and the applicable electrical codes. In addition to sealing requirements, conduit in hazardous classified locations must also be properly grounded to prevent the buildup of static electricity, which could serve as an ignition source. Grounding is typically achieved by using metallic conduit and ensuring that all connections are tight and corrosion-free. When working in hazardous classified locations, it is essential to have a thorough understanding of the applicable codes and standards, as well as the specific hazards present. Only qualified and trained personnel should perform electrical work in these environments. Always use appropriate personal protective equipment and follow all safety procedures. The National Electrical Code is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment in the United States. It is updated every 3 years to reflect changes in technology and best practices. Compliance with the National Electrical Code is essential for ensuring the safety of people and property. The National Electrical Code is not a law itself, but it is often adopted by state and local jurisdictions as part of their building codes. This means that compliance with the National Electrical Code is legally required in many areas. When installing electrical wiring and equipment, it is important to consult the latest edition of the National Electrical Code and any applicable local amendments. The National Electrical Code provides detailed requirements for a wide range of electrical installations, including wiring methods, overcurrent protection, grounding, and equipment installation. It is important to understand these requirements and follow them carefully to ensure a safe and compliant installation. The National Electrical Code is a complex document and it can be difficult to interpret in some cases. If you have any questions about the National Electrical Code, consult a qualified electrical inspector or engineer.